Okay, in this video we're going to talk about the trigonometric ratios and the way to solve for different parts of a right triangle using these ratios. So trig ratios are the ratios formed by the lengths of the sides of a right triangle. There are actually 6 of them, but we're only going to work with 3 of them. So these 3 ratios are sine, cosine, and tangent. And there's specific definitions that you need to remember when dealing with the trig ratios. And those are that the sine is the opposite leg over the hypotenuse, where if you remember that this is the hypotenuse, this would be the opposite leg. Well, it depends on which angle you're dealing with, actually. The cosine is the adjacent leg over the hypotenuse, and then the tangent is the opposite leg over the adjacent leg. And by opposite leg and adjacent leg, I'm talking about from the angle. So if we're talking about angle P, this is your leg opposite of angle P, and of course this is your hypotenuse. You should know when you're talking about hypotenuse, it's always the diagonal line that's opposite of your right angle. So if we're looking at angle P, this would be your opposite leg because it's opposite of angle P, and this would be your adjacent leg because it's adjacent to angle P. Now there is a mnemonic device that helps us to remember the definitions of the trig ratios, and that is SOHCAHTOA. So, sine is opposite over hypotenuse, ca is cosine equals adjacent over hypotenuse, and toa is tangent equals opposite over adjacent. So, SOHCAHTOA, that's the way to remember sine, cosine, and tangent and their definitions. Okay, so moving on, let's look at how it breaks down to a triangle. So here we have our right triangle, PQR, and if we're looking at angle P, our opposite leg to angle P, as I said, would be leg QR. Our adjacent leg would be leg PR, and of course our hypotenuse is PQ. If we're looking at angle Q, our opposite leg is PR, our adjacent leg is leg QR, and our hypotenuse would be PQ. If we're looking for our trig ratios, the sine of angle P, which is abbreviated sine of P, the definition is the opposite over hypotenuse, and we would show it as QR over PQ, or opposite leg over hypotenuse. If we're looking for the cosine of P, abbreviated cosine of P, would be adjacent over hypotenuse, and it's PR over PQ. Tangent of P, which is abbreviated tan of P, opposite over adjacent, and it's going to be QR over PR. Notice that the sine and the cosine are like complete opposites of each other, and as we get into these problems you will start to notice more of that they do reverse each other. Okay, so let's look at some numbers. If we want to look at the sine of D, then we're looking at the opposite over the hypotenuse, which would be 15 over 17. That's our ratio, and if we plug that into the calculator, we're just plugging it in as 15 divided by 17, and we're going to get 0.8824. If we're looking for the cosine of D, we're looking at 8 over 17. We plug that in, it's going to be 0.4705. And of course the tangent of D is opposite over adjacent, so it's 15 over 8. Right, because opposite over adjacent, yeah. Which gives us 1.875. Okay, so then if we went for the sine, cosine, and tangent of E, everything should be the opposite. We should have 8 over 17, which is still going to be 0.705. Cosine of E should be 15 over 17, which should still be 0.88 24, and then the tangent of E should be 8 over 15. Now this one I haven't calculated yet, so I will put it in 0.5333. So notice that they are inverses of each other when you solve them in the calculator. Or actually just the ratios are. Alright, so what if we want to look at how do we find the angle? So if we want to find the actual angle measurement, the sine of 52 or the cosine of 52, we're going to put it into our calculator. Now you've had these calculators forever, and I'm sure you've noticed where it says sin, cos, and tan. So to find that, first of all, you need to have your calculator in the correct mode. So you need to go to mode, which is up here by the second button, and come down and make sure that it's in degrees. So to do that, you would move down, push the arrows down, and you have your choice of radians or degrees. So you would want to push it over to degrees and hit enter. Whoops, I just moved mine out of degrees. Enter. And then clear it and get it out. So always make sure you're in degrees when you're dealing with sine, cosine, and tangent. So if we want to find the sine of 38, we simply push in sine of 38 and hit enter. And we find that the sine of 38 is 0.616. And the cosine of 38 is where am I? 0.788. And the tangent of 38 is also 0.781. Now we can do the same thing with 52. We do sine of 52, and you'll notice that much like when we did the ratios, they're going to come up and be opposites. 1, 6, just like before. Okay, so how do we use these numbers? Well, we can use them to solve and find missing pieces and or missing angles of right triangles. So let's look at this example 3. We have an angle, 53 degrees, we have a right angle, we have a side of 4, we have an x. So let's see, we know two sides but not the hypotenuse. So when we know two sides but not the hypotenuse, we're dealing with tangent, and we know an angle measurement. So if I want to set up this equation, I'm going to say the tangent of 53 equals, and I know don't know the opposite, but I know the adjacent, x over 4. So I would set this equation up like this, because I know my angle measure, so I would say tangent of 53 equals x over 4. So I'm looking for what is this missing side. So to solve this, I solve just like I do any other equation. So I'm going to isolate my variable. So I'm going to multiply this side by 4. So I would do 4 times the tangent of 53 equals x. So I plug it in my calculator. I find out that this side measures to be about 5.3. And that makes sense because you should know that, well, if this side is 4, to have a length of 5 makes pretty good sense. And this one over here, if we used a Pythagorean theorem, would come out to be larger than that. So again, what I did, I knew my angle measure, so I said tangent of 53 equaled opposite over adjacent, multiplied it to isolate my variable, and then I solved. So let's look at another one. Okay, so this time, I know the hypotenuse, I know an angle, and I know another side. Well, which side do I know? I know the adjacent side, so I'm going to use cosine. So I'm going to say cosine of 60 equals x over, this should not be degrees, 28. So again, isolate your variable. So I'm going to say 28 times the cosine of 60 equals x. So if I put that in, I get 14. I could have solved and gotten the cosine of 60, but I believe the cosine of 60 equals 0.5. It does. Go from there. All right, so let's look at one more. This time I need to solve for x and y. So let's solve for, I don't know, we'll do x first. So this time, if I solve for x, that's opposite of my angle, so I'm looking for sine. So I'm going to say the sine of 22 is equal to x over 14. So I'm going to solve it the same way I have the other ones. 14 times the sine of 22 equals x. Oops. I learned that this x equals 5.24. Now I need to find y. So I can do my y the same way. This time, since y is adjacent to that, it's going to be cosine. So I can say cosine of 22 equals y over 14. To solve, I would do 14 times the cosine of 22. I find out that y equals 12.98. And that's how you solve equations using trigonometric functions.